好，大家新年快乐，兔年大吉，万事顺意。好，我们今天来看一下这道2382。The problem statement is you are given an array first, then there will be several queries, and each query will give you an index. That means the query wants to find if I remove the indexed by order here. For example, I will remove the index here one by one, and after each removal, what is the maximum continuous non-empty array? I mean the maximum of sum of the non-empty subarray within the numbers. Let's check the first example. So the first remove query would be 0. So after removal 0, then the array becomes 2, 0, 2, 5, 6, 1. So the maximum continuous non-empty subarray is 2, 5, 6, 1. And the sum of this array is 14, right? 14. So that's the reason why the first value is 14. So, and the second query is remove the third index, which is 5. So after, not 5, it's 6. So after removing 6, then the remaining thing would be 0, 2, 5, 0, 1. So the maximum part is 2 plus 5, which is equals to 7. Yeah, so after that we got the, what's the meaning of the question, and we have a roughly overview of the problem statement. So what's the remaining thing? So if we start from the beginning, then we will need to find all the non-empty continuous subarray, which is a little bit hard. And I think this is a very typical time reverse or time machine reverse problem. That means instead of starting from the very beginning to the end, we will start from the end and then reversely look through the remove queries. So what that means? So let's look at the last index first. So after removing the last remove query, which is 1, then we got all 0 array. So let's say if we start from here, then we add this 1 to this empty array, what we will get? So we will get 0, 2 and 0, 0, 0, right? So based on that, we have much more convenience to get the maximum parts, because we will not change the existing things, but we will only add new things to the existing array. That means the new maximum value would be rather than the previous state or the new possible candidates. So for example, let's look at this timestamp. So for this snapshot of the array would be 0, 2, and 0, and 0, and 1. And then we try to add 5 to the array, and then the array will become to this 0, 2, 5, 0, 1. Right? So, and previously, so before adding 5, let's assume we already got one maximum value or maximum part sum, which is 2. But by adding 5, we are confident to see that after adding 5, there will be one more higher value, which is 5 plus the sum of the connected component of index 1, connected 1, right? And actually, so this part for this scenario would be 2, so which is equals to 5 plus 2. And then we check the index 1 before and 1 later. But for the later index, which is 0, that means there's nothing yet. So for now, we will only have one, not one, we will have a higher value with only two parts. And this two part sum is 7, which is greater than 2. So we compare the newly added maximum value with the previous maximum value, which is 2. Then we got 7, which is current maximum value. So by doing this way, we can first, we are easy to maintain the connected component. So there are two benefits of doing this. First is easy to maintain the connected component. And the second one is easy to calculate the newly added maximum subarray, right? So by doing this way, we start from the end to the beginning and maintain the connected component and calculate the newly added maximum subarray. Compare with the previous value, and we got the one new maximum value, which is the answer of the next index or next query from end to start. Okay, so that's the methodology. So let's implement that. Before doing that, first we need to maintain the connected component, right? So how to do that easily? So by doing this way, so we can use the union find to maintain the continuous connected component. So by doing that, we first need the size of the array, which is length of the numbers, and we also want the parent array, which is this value, typically. And obviously, we will need to know the value of the each index, right? So that would be this value. Okay, so this is the initial state. So for find index, there are many numerous templates for this function. So we can just use whatever you want. So I used to use this one, so let me use this. And the other one is union, right? So the union should be 2 inputs, and parent 1, parent 2 equals 2. Okay, so if P1 not equals to P2, then we consider connected them. So P1 should equals to the value of the P2. Okay, and then based on our discussion before, we want to iterate the remove queries reversely. So let's do this. So the length of the remove query is also equals to the length of the numbers, and there's one statement saying that the same index will not be removed more than once. So we can confidently say that we can just iterate the reverse queries. And we also know the index would be RQI, and candidate value should be so this is the answer. So we are doing after removal, right? So if we reversely, then we want to catch the thing that before adding new numbers. So one approach is so let me do this. So this A array will indicate if this number is added or not. And we iterate this remove queries reversely. And the problem statement saying that after removal, so the value we want to catch here is before adding. So this should be answer append the maximum value. So let me initialize that. So this should be 0. Okay. So after that, we want to update this value. So for now, the current number should be this value, and then we check the previous index, which is index minus 1. So if this is bigger than 0 and the number is already there, only in that scenario we want to calculate something. So for this, we want to we can do either way. We can union first, then query the sum. No. We don't want to union it before query the sum. So let me find that. So the parent of the index minus 1 should be this, and the sum of this connected component is find the parent of the index minus 1, and then the candidate will plus this number, and then we want to union them, like index with index minus 1. And also same thing for the next or the later value, and this should always smaller than n, and this value should not be 0. Okay, so this value is im and find index plus 1 and candidate plus this value and union them, index and index plus 1. Okay, after that we want to add the actual number here, numbers index, and then update the possible candidate with the global maximum value. Okay, so after that we want to return the answer reversely. I think that's it. We have all the things, so let's check one by one. First, the parent array is correct, and the length of the numbers, and the initial map, find function, and union function, and the condition to find and union, and the timestamp we want to add. Yeah, perfectly. Yeah, I think that's it. So let's try. Okay. Oh, it's a typo. It's a typo. Okay, it looks good. Let me submit it. Okay, it passed. So let's do the time complexity analysis. So overall, the time complexity is for this find and union overall, it should equals to something of the reverse Archman function. Reverse Archman function of the union find. So union find parts. And this value should equals to something of the SQRT of but basically this just, we can treat this as a constant. It's very small, and if you want more details you can check the OIV key for this part. And the remaining part is how we iterate and how we do the find and union, right? So basically we're doing a union things, a linear things, so the overall time complexity would be linear, and the space complexity would also be linear because we have multiple arrays and hash map to store the information, so both of them are linear. So that's it. So let's try to use the Java as well. So for Java, I like to simplify the procedures here, and yeah, so M and P and what? And we also want the overall length. And what? And that's it, I think. So let's initialize them first. So n equals to the number's length, and p should equals to okay, so this is actually not the same uniform value, so we need to iterate them. So pi should equals to I, and so let's initialize m as well. And the m values here, so we use the m to store the sum of the values, multiple values. So I would say this is actually a long array, not the integer array. So let me do this. And goes to the numbers I. Okay. So for the find function, and for the union, and only they are not same, then we will consider to add them up. So first, let me do this, assign the root value, and then this should equals to n plus equal np2. Okay, that's it. Then we also want integer array which is a, and the length of that should equals to here, this way. Okay, and for the long array answer, let me initialize that as well. And then do that reversely. Goes to I equals to n minus 1, and I bigger than 0, and I minus minus, and the long value final or maximum sum equals to 0 first. Then yeah, so the answer I should equals to max s. Then the two assertion, first is this should be bigger than 0, and this value should not equals to 0. Then we do so first we want to get the sum of the connected component, which is m. Then find, oh sorry, so it should be something like this. RQ then find index minus 1, do the candidate, then candidate, then union them, and same thing for later index should smaller than n, and a index plus 1 minus 1 should not equals to 0, and then the PCS should equals to find index plus 1 and union them. After that, we want to assign the value of the index to the actual value, and we also want to update the global maximum. Then goes to this. Then that's it. Then we can just return the answer. Oh, okay. Sorry. Should be long. Okay, it looks like it has some issues. Why is that? Oh, okay. So this value should not be 0. It should be this. Still some issues here. And yeah, we don't want to assign this. We want to assign the I. Okay. Yeah. I think that's it. So let me try more examples here. Okay, it passed. Should I write the C++ as well? I don't think I need to do that, but let me try. First tap def, long with LL, then same thing. So we want the integer vector. Oh, okay. Yeah, let me try. So vector of int and a in int a equals to no, equals to the numbers dot size, and we want a long array or vector of long array, which is the m size of and in order to do the find function, we also want the parent array, and let's initialize the values. Okay, then pi should equals to I, and I should equals to numbers I. So for a, if we initialize this with the initial value should be 0, then we don't need to assign values here, but let me write the find function equals to this, then integer x. So if x is not equals to px, then px should equals to find. Okay, so let me write this auto find px, then return px, also auto union. Oh, okay, let me un want to in parameters here, and int p1 equals to find x, int p2 equals to find y, and if p1 not equals to p2, then we do two things. First is assign the parent of p2 to p1, then we add the map. Okay, that's it. Then we want to construct the values, which is vector ll and answer. We also want a long value global maximum. Then iterate reversely. So first assign the values equals to max s, then get the actual index rqi, and to assertion, oh yeah, we will also want the candidate as well, which is ll candidate, and, oh sorry, this is not 0, it's numbers index. Then we check two things. First is this is bigger than 0, and right over there. This is not equal to 0. Then we do first we calculate the PCS, which is equals to find index minus 1, and candidate plus this value, and union them, which is union index and index minus 1. Same thing for the later one, is smaller than n, and a index plus 1 is not equals to 0. Then we calculate the sum of the connected component, and the plus of values here, and finally add this and union them. And update the global maximum equals to candidate. And we also want to assign the value of the index to the numbers index. Then return the final answer. Okay, I should say this should be something like this. No matching function call. Oh yeah, so this is actually this. Same thing here. And here as well. Find. Okay. Then if I'm using auto, maybe I should not explicitly write the return value here. Operator deduct return tab before it. Okay. Factor of int. should I write this explicitly? Function of int and int. Not sure if it's correct or not. Okay, so let's ask ChatGPT. So, give me a template of union find with C++. So lambda function for find in union find. No, that's not the function I want. Okay, so we try to find that out. Why this is no matching function call to object of type. Oh, I see. So here it should only use this, I guess. I don't need that. Find. So let's try. No pointer issues. Why that? Oh, this is not long. Might be the issues. Okay. we don't do this, am I still getting okay? So the issue is here. So let's do this. Okay, so the issue would be something here. Answer I. Oh, here I'm not initializing S, so this should be N. Okay, then we get correct value. Let's check. Yep, it passed, and we learned this, but I also want to try this with lambda function way. So find equals to this, then auto find int x, then if x not equals to px, then px equals to find px. I want to find out why this is not working. Oh yeah, so this need two parameters here and here as well. So what's the issues? Lambda with reduced deducted return type cannot be used before it is defined. Shall I do this? Oh yeah. Okay, so this return tab, because I'm using it here. Okay, so this is also a valid way. Okay, and the other thing I want to verify is, yeah, I think that's it. Okay, so this is this problem, which is typically time. So the topic should be time reverse plus union find. This is a very typical problem of this topic. Hope you guys have a very good New Year of Rabbit.